All right, students, welcome back to this second video of chapter 4. Okay, and this video I'll be covering 4.3 first, about law of logarithm. We have done law of indices in the 4.1 video. So in this video, we will be doing in detail about logarithm. But before I start, I want to tell you all certain things first to inform you all about certain things that are important, all right? Firstly is that I've introduced timestamps below in the description box and in the comment section below. So you can actually skip the video to whatever questions you want to view it at your own convenience, okay? So make use of that timestamp. And then I've also included the resources, which in this case is the notes for the topic that I'm using. It's the exact same copy that I'm using here, right? So that's where you can get your resources. And along the time, if I have more things to share with you guys, I will just include it down there. I'm like growing my channel now, so I'm doing it slowly. So there might be a lot of mistakes that is happening. But I hope you all can grow along with me. And I would like to apologize, right, for my first video for making some careless mistakes. I don't give any excuse, but I made some careless mistakes. But I did the correction behind every mistakes questions, okay? And as well as the editing is not very good, but I hope that the content is there lah. All right, and I'm improving also, okay, to speak a bit slowly and perhaps not to, because I tend to want to say too many things in a short time, so I tend to rush, and that causes a lot of sometimes confusion. Once I view back, then I realize it. So I'm improving. I'm slowly improving lah for y'all. Okay, and then as well as my writing is very disorganized. It's very ugly. Okay, I scribble here and there. Hopefully this video, right, when I'm doing notes, right, I'll write the discussion points on the right hand side here. And then when I'm doing questions, okay, when I'm doing questions, I will do the questions on the right hand side if there is space, using blue color pen, and if there is no space, I will do it another page. I will just add a page like this. Next page. All right, I'll do the next page. That's what I want you to know about what I've realized from my first video. Okay, it's a mistake. You see, I realize it's a mistake. Then I try to improve. Same with y'all, okay? But for y'all, it's your Add Maths or your life. Whatever mistakes you make, don't forget ever to not repeat them. Okay, so I don't want to waste any more time. We will start straight away with chapter 4.3, which is laws of logarithms. Okay, before we start logarithm, we must know what is actually logarithm. Okay, we tend to hear the word a lot about logarithm. People tend to get scared of the word logarithm before this. When they see the sign log, I remember myself when I was in like Form 2, Form 3, I see the word log, oh, I'm so scared. Because it looks very high class, complex. But in fact, it's actually not very hard. It's just another way of writing an equation. An equation is another way of writing, another format, another form of writing it. There are some purposes of logarithms, okay? Everything has its uses. Okay, so what do you have to know about logarithm in your syllabus is that when you have a base to the power of an index, okay, we have learned this is known as the base, this is known as the index in the previous video. Okay, mind my voice, if my voice goes away. All right, if I have a base to the power of an index equals to an answer, I can actually rewrite, okay, the word is rewrite, this index form. This is known as the index form. Why do you call it an index form? Because you see an index. Simple. It's very simple, right? Because it is index. You have a base and index. That's why you call it index form. So in this subtopic, you must learn how to convert index form to logarithmic form. Oh, okay. So how do you convert it? I just call it logarithm form lah, logarithmic form or logarithm form lah. Okay, so how do you convert it? Form. How do you convert it? Is what we are going to learn. And it's what they're going to ask you if they are kind to you, because this is a very simple question. Okay, so we look at a to the power x is equals to y. I want you to know that this is the base, this is the power, and this is the answer. When we rewrite it to logarithmic format, I want you to know that this can be written in a form of log a y is equals to x. I'll teach you how to memorize it later. Okay, I'll teach you how to remember it later. Basically, right, when you look at this logarithmic form, what you realize is, I want you to remember, look at the left-hand side. Log ay is equals to x, right? I repeat writing lah. So I write it bigger, you can see. I want you to think of this. When you look at this, right? When you look at this, what does it mean? It means that a to the power of x is y. Can you follow? I repeat. Okay, for example, b is equals to c. What does it mean? You must know that, okay, the base, okay, we see the base a. First of all, we notice that the base a is actually bottom here. Okay, I try to make it more simplified for you to see. This is y. Okay, we have log a y is equals to x. Okay, first of all, you must recognize first the base would actually come here. The y, which is the answer when you calculate a to the power of x, would be the one here. And the power or the index would be the answer for this form. Okay, I want you to recognize it. In other words, right, I give you an example. 2 to the power of 3 is equals to 8. Okay, 2 to the power of 3 equals to 8. Why? Because you multiply 2 times 2 times 2. How many times? 3 times. Because it's power of 3. It's known as the cube. Okay, so you multiply by 3 times, you get 8. Don't ever make the silly mistakes of 2 power 3 equals to 6. This is a very common mistake. If you still make this kind of mistake, means you have to really brush up on your basics. Okay, so 2 to the power of 3 is equals to 8. When I change it to logarithmic form, how will it look like? Don't forget, log, it will become log, and the base will always be the small number beside the log. The base will always be the small number beside the log. And then the answer to this 8, the 8 here would actually come here, equals to 3. Basically, in logarithmic form, I want you to remember that the answer on the right-hand side here is actually the power. You can think of it this way. Okay? If I want you to look at this thing this way, I want you to every time I see a logarithmic form, I want you to say this sentence. Say this sentence, repeat after me. Okay. 2 to the power of what? 2, you see there's a 2 here. 2 to the power of what will give you 8. 8 is here. Okay, you want to ask yourself a question like this. 2 to the power of what gives you 8? This is a simplified way of understanding this logarithmic form. Okay, you're basically asking yourself 2 to the power of what will give you 8? And yes, the answer is on the right hand side here, 3. You get what I mean? A lot of people do not know how to interpret this logarithmic form in this manner. So they might get confused sometimes. Oh, I forgot how to convert. I forgot the formula. You get what I mean? So whenever you go, right, wherever you go, when I've logged to the power of x equals to y, basically, right, you're asking yourself, there's a here. Okay, the sequence is a, then x, then y, right? You ask yourself, a to the power of what will give you x? And the what is actually a y. Okay, you can look at it. You can look at it from the left and to the right. Okay, so when you look at it from the left, you ignore the right hand side. You ask yourself, a to the power of what gives you x? Okay, and this what is actually a y. I want you to be able to ask yourself like this when you're dealing with questions like when you're understanding and interpreting this logarithmic form. It's very important for you to actually absorb this in this way, and not just memorize. Oh, if I have a to the power of x equals to y, therefore I memorize log a y equals to x. Log base a, y equals to x. Okay? Which is not correct. I give you one more example. Okay, let me give you 16 to the power of half is equals to 4. Okay, as I repeat in the last lecture, in the last video, power of half is actually square root. Why is it square root? Why is it square root? I hope that you can recall. I've taught it. I'm going to briefly go through. Why is x to the power of half equals to square root x? Why? Why? Okay, remember, when you have a power of fraction, don't forget the name of power root. Okay? It doesn't matter you do the power first or you do the root first. Okay, for this case, I do the power first, okay? So x power of 1, power will always be on top here. Then you root it. Root is you root 2. So root 2 is known as what? It's called a square root. You don't have to put the 2, okay? It's automatically known as square root if you draw this sign. If it is cube root, then you have to put the 3. Okay, if it is root to the 4, you have to put 4. But for this case, it's square root, you don't have to put, okay? Square root, you don't have to put the 2. So it's actually this. I repeat again, because I scared you forget or you did not view that video or you missed certain parts, you skip the video. Okay. So we come back to this. 16 to the power of half gives you 4. So I want to change this to logarithmic form. Okay. So you must ask yourself, now you know that 16 to the power of half gives you 4. Okay. So the base is 16. Okay. The base is always the one that has power. Okay, so log 16 to the power of 16 to the power of half will give you 4, right? So is log base 16, 4 equals to half. Remember, I told you the power is always the answer. Remember? Just remember 2 things. The base is always the one next to the log, the small number. The base is always the one that is going to be the small number beside the log. And the power is going to be the answer. All right? So the third variable, you can automatically fix it here. Okay, and then I told you not to forget, when you see a question like this, you must know how to interpret them. What does it mean by this? For example, if they give you this statement only, this statement, log base 16, 4 equals to half. What does it mean? I want you to be able to tell yourself. Go one by one. 16 to the power of what? 16. This statement means 16 to the power of what? To the power of what will give you 4. And the answer is on the right hand side, which is half. Okay, you must be able to interpret the words like this, okay? So that is actually basically everything you need to know about conversion of this kind of things lah. So if you notice, I told you, right, I leave a 1/3 section here for you to write your own notes. But since I don't have enough space, right, I would actually erase them, okay? I will erase this 1/3 section. And I hope that you have written down the notes, because I'm going to rub after I teach this, okay? Pause the video and write down the notes if you need to. I'll just rub it off now. All right? Okay, so I move on now. Since just now we have converted from index form to logarithmic form, now I'm trying to convert back from logarithmic form to index form. Example, just now we have an example, log base 16, 4 is equals to half. Okay, don't forget to interpret this. These are 16 to the power of half is equals to 4. Or you can ask yourself a question. 16 to the power of what will give you 4? Okay, the answer is half. Okay, 16 power of what will give you 4? The answer is on the right hand side, half. Or if you are good enough, you can straight away know, or 16 to the power of half is equals to 4. Okay, you move to the right, then move back to the left. You can find your own way to memorize it lah. If you do not want, you can just follow my way. Because my way will encourage you to think, okay? 16 to the power of what will give you 4? And the answer is on the right, which is half. You can think of it this way. All right, so this is the logarithmic form. How do I convert back to the index form? Log form. I just write in short form, log form. How do I convert back into index form? Is that first you start with the base. Base is 16. Okay, you remember just now I told you, right, that the power will be the answer for the log form. Remember not, I told you just now, the power, the index would be the answer for the log form. So if you reverse the process, you think of it, the answer will actually be the power of the index form. You get what I mean? This half is actually the power. 6 to the power half is equals to the last thing, which is 4. All right. This is quite important. Or you can write down a note to yourself, okay? The note to yourself you can say is the index or the power will become the answer for log form. What do I mean? If I have x to the power of y is equals to z, okay, you see, you know where the base will go. The base will actually stay next to the log, always, okay? The base will always stay next to the log, okay? And you know that this power will be, so you put an answer of y first, then the z will automatically fall here, okay? The z must write bigger a bit, basically normal, okay? It's only the x that will be written smaller because x is a base. So base, you will write it smaller. So this is all for converting. We'll do some questions later. So now we move on to law of logarithms. Law of logarithms is very similar, like what you learned in your 4.1. Not similar. I mean that they are related, like they're like opposite of each other. So you can see them individually first. I did it in 4.1 and I'm doing it in 4.3. Then later on, when we solve equation, they will mix everything up. And there are some questions which are quite tough. Okay. So law of logarithm, you must know there are only 3 of them. Actually, are there only 3 of them? Yeah, 3 of them. But there are some special contents you need to know lah. Some special you need to know about log, which I'll cover with you also. So the first law of logarithm is log axy is equals to log ax plus log ay. As usual, when you are using a theorem, when you're using a law, you must always understand it to the deepest ever possible case. Why? Why you want to do it? Because everything, all the questions that you're going to see in the exam are going to arise, are going to be built upon these 3 things only. So you must, if you do not know these 3 things very clearly and very thoroughly, you have a hard time, okay? So you must be able to spot that there's a multiplication between x and y here. There's a multiplication x and y, and this multiplication will split this one into log ax plus log ay. All right? This is the first theorem. Later, I will go through some commonly made mistakes by students. I go through the theorems, so through the law first. Second one is when you have log base a, get used to the way of saying it. Log base a of xy, of x divided by y. This is the second law already. Similarly, when you multiply, it becomes plus. When you divide, it becomes minus. Okay? This is basically the first 2 laws. I want you to try to remember first. Try to take a look of them first. A look at them. Okay? And the third law is log ax to the power of n. Okay, now this n is the power of x only. Take a note down. N is the power for x only. Take note, I'll rub this off later. N is only the power for x, not the whole thing. If they give you something like this, another commonly made mistake. If they give you the power like this, log ax to the power, okay, this is different from above. You must understand. This power of n belongs to the whole thing in the bracket. As I always mention, bracket has priority. If the bracket says this thing is inside the bracket, means the n belongs to the whole thing. But for the top one, there is no bracket. So it means that the power of n is only for x. Can understand? Okay, this is a good common mistake that I want you to write down. I want you to write down in the 1/3 section. That's why I created for you. Okay, write it down. This kind of commonly made mistakes. I hope you write it down, because I don't know whether you're watching everything or you're just skipping. I hope that you really watch everything. This is the first commonly made mistake. Okay, but before I go on to the next others most commonly made mistakes, I will go on to the third law first. When you have log x to the power of n, the n can bring down. Don't forget, this is a very, very important thing that you must know what to do, okay? The power of n can bring down. Okay? How can you bring down? Just bring it down lah. Becomes n log ax. Then this n disappears. Simple as that, okay? It's only this three law, but must get used to it. You see, people tend to know these laws. They know. When I ask them what are the three laws of logarithm, they can tell me. But when it comes to something that they do not know, basically a law they do not know, they think, yeah, I think I've seen it before. I think I'm assuming, I think I've seen it before. Something similar. Then they will get caught there, they will get tricked there every single time. For example, I give you one example. Commonly made mistakes. I want you to write down. When you have log a of x plus y, you see, normally when you have a normal algebraic expression, a to the power of x plus y, what will you get is you multiply a inside, you get ax plus ay. Okay, I repeat again, when I write them together means it's multiplication in between them. Correct or not? But that doesn't mean that these students would think, oh, I've learned this before, so I think this one also the same lah. What I do is I do log ax plus log ay lah. This is wrong. Salah, 错的. 明白吗? This is not correct. And I emphasize this very much because even I think most of the people have made this mistake before. Even if they haven't made this mistake before, they have at one instance would have thought of this possibility before. You get what I mean? Even me myself. When I wasn't that sensitive with this kind of stuff, when I wasn't that good in logarithm, I would tend to think like this because it's common for humans to use what they know to explore what they do not know. So since this one worked, this one should work also. But whether it really works or not, you must really find out. Okay? Another chapter, right? That I don't know whether I'll cover or not. It's about matrices. Matrices is also another tricky thing, It's not like normal algebraic where you can simply times and plus thing. In matrices, order is very important. I don't know whether I'll cover matrices or not, but if I were to cover, I would tell you the same thing, okay? So it's that's all lah. I want to tell you this common mistake. Similarly, if I have let me see, another commonly mistake is that this one, log ax over log ay. What do you think you can do with this? Are you thinking something like this? Ax over y? Are you thinking of this? Or maybe cancel the log a. Oh, this one even better. Super genius. Become x over y. Better. So if you are either one of these two students, you know that these two are wrong. And it's not wrong to think of this if you're learning it for the first time. Because it's normal. It's out of human curiosity to apply things. So it's a very good step if you actually think of this. And now tell yourself it is wrong. It's a must to tell yourself it is wrong. You have to make it clear, organized, format, store the files in your brain as if you're storing in computers. Must be systematic so that when you want to extract the files, it's way simpler. Okay? As I mentioned many times in the first video itself also, clarity is very important. Whatever you do, clarity is one of the most important things that you do, okay? That you want to do. So these are the commonly made mistakes. Let me see, are there any made mistakes or not? Log a x square. Okay, one more. I want to tell you one more. One more. I'll just write it down here, okay? Oh, not. I'll just write it down here. The mistake is on about this. It's about the third law, okay? When I have log a, b, c to the power of n, okay, you see, this n belongs to this c, does not belong to the b. Why? I don't have a bracket here, okay? If I have a bracket here, means n is for this bracket. You understand? But if there is no bracket, means n is for the closest variable. which is C. Okay, so can you actually bring it to the front, become n log ABC? You cannot, okay? Why you cannot? Why you cannot? Go back to the theorem. Wait, I don't want to rub it. Why cannot? Okay, why? Go back to the theorem. The theorem says that log AB, they use B or what? It doesn't matter lah, huh? Or log AXN. Log AXN is equals to n log AX. You see, there is only one variable here. You get what I mean? So this n must be belong to only one thing. Only you can bring it forward. I repeat, this power n must be belong to only one thing. Only you can bring it to the front. Okay, then I give you another example. I give you another example. See whether this is one thing or not. What if I've log ABC now in the bracket to the power of n? Can you bring this to the front? Can you bring it to the front? The answer is yes. Why? Because this bracket is making this thing one thing, which means that the power belongs to only one thing, which is the thing in a bracket. You get what I mean? But if you compare it to the top right, there are two things here. What are the two things? B and C. And this n only belongs to C. And we have two things. You cannot bring the power of n in front. And what you're supposed to do for this one, if you were to solve this, is you got to break it up first. Log ABC power n. What you do is you got to break it up. Okay, this base is A. I write it in different color. If not, you will see differently. The base is A down here. How do you break it up? Use law 1 and law 2. This B and C to the power of n, in the middle of them is multiplication. So if it is multiplication, you can split the log into two logs and you add them together. Why you add? Because it's multiplication here. So you split them into two logs, becomes log A. Okay, copy the log A, B plus log A, C to the power of n. Now, you write back log A, B plus this power. Can you bring forward now? Ask yourself, can or not? Look at it. This n belongs to how many things now? It only belongs to C, which is only one thing. So yes, you can bring it to the front. And log AC. This is what you do, okay? This is the brief ideas I'm trying to brief you through first, okay? I'm just running you through. Because later when we are dealing questions, right, we're going to do a lot of all these things. Oh, sorry, have you guys copied? You guys can take notes yourself, okay? Because I still haven't found a way to actually to have enough space to write. I thought of actually opening two screens to write, but it's not working. So if you have any advice to me on this, you can tell me, okay? On maybe video editing, on anything that you see I'm lacking of, you can actually inform me in the comment section below, or you can PM me. All right, it's helpful for me so that I can create more valuable content at the end. Okay, so this is what I want to discuss with you, and I'll rub it off now. Okay. All right. The number one rule is always your mindset, as I said, okay? As I'm rubbing, I'm telling you, the number one rule is always your mindset. At the end of this chapter, right, you will see some very, very tough questions, you know. But if your mindset is telling yourself that you won't do it, you definitely not do it. Okay? I don't talk too much. If not later, this video is going to be so long again. I've got to track, you know, how long is this video? If not later, it becomes too long. Let me track. How do I track it? How do I track it? Okay, never mind. It's all right. Oh, sorry. It's all right. So, and I want y'all to also let me know in the comment section below. If you can, let me know on whether you prefer this kind of long and detailed version videos, or you prefer short and brief. Because some people tend to like different kind of video styles. So just let me know about your opinion. Or maybe I can find an optimum between long and short. Or I can do some other ways. I can separate notes and exercise. Or I can do different things. So you must let me know. As I told you, I'm growing, I'm learning. I need to have as much feedback as possible. I'll wrap everything off now. I hope that you have written down in your wanted section or in your own notes. Okay, so now I'm done with this. Now I'm done with law of logarithm. Very good. Now I'll move on to some special identities, some special unique thing that you need to know. Okay, first is known as the anti-log, but never mind, I won't go through this yet. I'll go through the rest first, then I come back to this. Okay, when you have log of something and this is the same thing, for example, log XX or log AA, log BB, log CC, log DD, it will always be 1. Okay, why? You see, if you follow my method of studying, right? If you follow my method of studying, what is actually log XX? What is it? Okay, if you know what I taught you just now, I teach you how to interpret, right? How do you interpret? This actually means this x has to power of what to give you this, which is also x. And you know, x to the power of what gives you x? It must be 1. Because as I mentioned many times in the first video, when you power a variable by 1, it will output the same thing. Means if x power of 1, it will give you x. If I give you a to the power of 1, it will give you a. If I give you Brian to the power of 1, it will give you Brian. You understand? That's why I teach you how to interpret this. You don't just memorize. So as I can see, x to the power of what gives you x? I know it's 1. That's why the answer is 1. You understand what I mean? Okay? If it's still manageable, we move on to the second, this one. So you must know anything you log A, if this number is 1, if it hits 1, the answer is always 0. Similarly, you can use the method I taught you on how to interpret. This question is something like you're asking yourself, a to the power of what will give you 1? So if you recall your 4.1 lesson properly, right, you will know that if you want to power something to get, if you want to power something to get 1, it's always 0. You remember not? In the lesson we learned a to the power of 0 is 1. So in other words, right, when you look at this log form now, I look at this log form, a to the power of what gives you 1, you know it's 0 because you learned in 4.1. So this is another understanding thing that I want you to interpret. That is why I ask you to interpret the way I teach you just now. A to the power of what gives you 1? A to the power of what gives you a? This is what I want you to do. Okay. There's a reason why I'm doing certain things. So I hope that you all follow me. Okay, log A0 is undefined. What is undefined? Means that it's a maths error. It's cannot be defined. You cannot define it. There's no answer for it. Not to say there's no answer. It's illogical, you know. Okay, basically, you see, a to the power of what gives you 0? This is the question, okay? A to the power of what gives you 0? Okay, a to the power of what gives you 0? You can try values yourself. If you do not know what I'm trying to tell you, try values yourself. Okay, let's give a number, 2. 2 to the power of what gives you 0? Think. 1 to the power of 1 will give you 2. 2.1 give you 2. 2 to the power of 2 will give you 4. Also, it's getting bigger. Let me go smaller. 2 to the power of 0.5, what will it become? It will become square root 2, also not 0. You can keep trying. You will notice that there's no value that will give you 0. There's no power that would turn this thing into 0. That is why when there's no value, you call it undefined. Okay, so log anything to the power of log A0 is undefined. These 3 things is very special identities, special things you need to take note, because these are the tricks and shortcuts that you can somehow get fluid when you're doing questions. All right, and the first one is actually the anti-log method. What is the anti-log method? You seldom use this, okay, but sometimes it might ask maybe 1 in 100 question. All right, so I want you to know what is the anti-log. Okay, first of all, you must know that what is the anti-log is when you have a to the power of log ax, it will give you x. When you have a log a something, this something will come here. You see, not this a, this a. You see, this, I want you to spot this intelligently. This log ax is in the power. It's not times, it's not like this, you know. A log ax, not like this. It's a to the power of ax. You understand me, right? Wait, let me check whether I'm recording or not. Okay, I'm recording. If I'm not recording, then it's going to be funny. Okay, so this is the log ax is the power. And if this base is a and the log here is also base a, you can straight away write the one on the right hand side here, down here. Okay, example of question is when you have a to the power of log a 7x plus 1. what is this answer? You know the answer is straight away 7x plus 1. You just copy this thing down here because it's a log a. But don't forget, this must be in the power. Understood? Okay, proving. Why is this happening? Okay, I won't try to prove very complicated, okay? I will just prove to you as simple as possible. Okay, you all know that log ax is equals to what? Log ax, correct or not? Log ax is equals to log ax, right? This is logical, right? Brian is Brian. A mouse is a mouse. A prune is a prune. A fan is a fan. A key is a key. Log ax is log ax. They are equal to each other because they are the same thing. So now I want you to think of this as log ax is equals to n. Can you see? This is n. Can you see? I want you to convert. Okay, so you try to treat this as a logarithmic form. I want you to convert to index form. How do you convert to index form? Okay, so if you know how to analyze this question, right, you know straight away log ax means what? A to the power of what gives you x? You know that a to the power of this right hand side thing gives you x. Remember, I told you the right hand side is always the power. Don't think of it as log on the right hand side. Think of it as a thing. Okay, think of it as a power. Think of this log ax as a power. Okay, or you can put a bracket there. It's like a power now. Don't think of it as log ax on the right. Okay, so now you have some log ax equals to, I put in a bracket, log ax. So a to the power of this thing gives you x. Okay, so I write it down like this. A to the power of log ax from the right hand side. A to the power of log ax gives you the answer, which is x. That is why I arrived to this. Okay, this is a concept that most teachers won't emphasize on, this anti-log thing. Okay, but somehow this question is a bit special. When they want to ask you this question, it's very obvious that they're asking you this question. I've included maybe like 2 examples in the question section below. So I'm just teaching you everything now. Hopefully you can learn well. All right, so we are done with all possible things already. Okay, and I included in this page as well, in this notes 4.3, changing of base. Okay, because I think you should learn it together lah. It doesn't matter, you don't need a separate topic to learn it. Changing is basically explaining itself. You're trying to change the base. You see, I don't like base A, I want to change to base B. Why you want to change to base B? Because in many cases, when you look at the questions below, right, when you want to solve the equation, you find that you need to change base sometimes. You understand? Because you want to make the base the same. So if you have 2 different base, you have to make this one to be same as this one, or this one same as this one. So that's why you need to change base. That's why we are learning how to change base, the technique. Okay, so what sits up there is always the same. What sits up there is always the right hand side one. What sits down there is always the left hand side one. Okay, or you can think of it this way: the right hand side one will go up, the left hand side one will go down. Understand? What is on the right goes up, what is on the left go down. Okay, so that is on changing base. Okay, all right.